So let's continue. Let's copy down the information. 74. Okay, 74 on page 559. So a total of 45% of students sleep between 5 and 7 or between 9 and 11 hours. The difference in the percentage who sleep between 5 and 7 hours and between 9 and 11 hours is 41%. So difference, 41%. Find the percentage of college students who sleep between 5 and 7 and the percentage of college students who sleep between 9 and 11. So how many variables we have in this problem? Two variables. I'm going to call this x, and I'm going to call this y. X is the number of students, or the percentage of students, in this case, who sleep between 5 and 7. And y is the percentage of students who sleep between 9 and 11. Okay. How many equations we need in order to be able to solve a word problem or any problem with two variables? Two equations. Very good. So let's come up with two equations. Any suggestions? Yes? Say it again.
5x minus 7y.
This has nothing to do with the problem. These are just two categories. It's like with kitchen or without kitchen facilities. Yes, I'm ready. Tatiana, go ahead if you want to. Indeed, awesome. X plus y equals 45. Absolutely. Second equation. So x minus y, so the difference is 41. Okay. Now I don't know if it's x minus y or x or y minus x, but it doesn't matter. We can adjust that later, and we check the solutions anyway in the original system. Perfect. So this is a typical situation in which I can immediately add. I should not waste my time to do anything else. So then I get 2x equals 86. So then x equals 43. If x equals 43 and their sum is 45, what should y equal to? Indeed, of course, percent, of course, percent. So our solution appears to be this. Yes, true, but we should still go back and check. 43 plus 2 is 45. Yes, it is. 43 minus 2 is 41. Yes, it is. And this is done. Any questions for me? Any questions? Okay, our next step is 5.4, which is systems of non-linear equations. Systems of non-linear equations. Now, the three possibilities from before are not valid here anymore. We're not talking about lines. Anything can happen. We can have one solution, we can have two solutions, we can have three solutions, we can have four solutions, we can have anything, right? So those three options are only valid for linear equations. Two variables, and two equations in two variables. One solution, because two lines can meet in one, cannot meet, it's possible they don't meet at all, so no solutions, or they meet in all. I can't have two solutions or three solutions. I can have infinite, I can have exactly one, or none. This is a totally different story now when we talk about non-linear systems, or non-linear equations in other words. Okay. The techniques are the same. Substitution and elimination. No secrets there. Okay, so I would like us to go to page, and then we'll look at word problems as well. Page 587. So let's start with 12, in which we have x squared plus y equals 4 and 2x plus y equals 1. I will not, on your test or final exam, I will not indicate the method. There is only one method that I have to indicate, but here it's up to you. And for this particular problem, we are, however, asked to use substitution. In this case, we can use, for this particular problem, we can use either one. If you decide to use substitution, it doesn't matter. You can use, or you substitute or solve the first equation for y or the second equation for y. Not for x squared, of course, from the first, or x from the second. So if you decide to, which one would you want to solve for? The first or the second? The second one. Okay, very good. So we want to solve for y in the second one. What do we get? Right, so let's put it in descending order. That's correct. It's not a mistake. You can write 1 minus 2x. That's perfect. And then we have to replace it in the first equation if we use substitution, right? So then we will have x squared minus 2x plus 1 minus 4 equals 0. I immediately moved 4 to the other side because it's quadratic now, and we have to solve for x. So I simplify, combining like terms. And then I hope that I can easily factor and get the two solutions, or the two options for x. Can anyone factor for us? X squared minus 2x minus 3? X minus 3 and x plus 1? Very good. And then we have x equals 3 and x equals negative 1. This is good, but it's not enough. We have to go back and solve for y. So when you plug in the y, negative 2x times 3 plus 1, what would you get for y? Three times negative 2 is negative 6, plus 1 is negative 5, and negative 2 times negative 1 is 2, plus 1 is 3. It happens that this system, as I mentioned before, because it's not linear, it's non-linear, the first equation is not linear. The second one happens to be, but the first one is not. Well, what are the solutions that we just determined? Yes, 3, negative 5, and negative 1, 3. Of course, we'll go back and check. I'm going to copy the system here just for us to check. So we have x squared plus y equals 4 and 2x plus y equals 1. So we will replace first by 3 and negative 5 and check, and then we will replace by negative 1 and 3. So let's do that. So 3 squared is 9. 9 minus 5 is 4, yes. 2 times 3 is 6. 6 minus 5 is 1, yes. And we will go back and check the second order pair with negative 1, 3 and negative 1, 3. So the first one is 1 plus 3 is 4, yes. And the other one is negative 6. I'm sorry, it's negative 2 plus 3 is 1, yes. So, of course, both solutions work as expected. And this is the solution. In this case, there are two ordered pairs that form the solution. 3 comma negative 5 and negative 1 comma 3. Okay, so let's look at 14. Same page, 587. And then we have xy equals 4 and x squared plus y squared equals 8. In this particular situation, we cannot use elimination, even if we wanted to. It's not possible. We don't have the same variables. Here we have the same variable. So if I multiply, let's say, the second one by negative 1, I can eliminate y. But in this situation, no, I cannot. I have to solve for either x or y. From which equation? From which equation? Yes, I cannot do anything to the second one, or with the second one, of course. So you want to solve for either x or y. It doesn't matter. We have no choice now. If we want to solve for x, then we have 4 divided by y, and we have to plug it in the second one. So we have 16 divided by y squared plus y squared equals 8. This is not a trivial equation, right? It has the variable in the denominator, which makes it rational. So 16 over y squared plus y squared minus 8 equals 0, as we did a long time ago. And of course, y cannot be 0. Now we have to find the least common denominator. In this case, the least common denominator is, say it again. Yes, perfect, y squared. So we need adjustments. What is the adjustment for the first fraction? And the answer is? Very good, awesome. Thank you, Brian. The answer on the second one? The answer on the second one? It's over 1, right? So what is the top? If I start with 1 and I end up with y squared, I multiplied 1 by y squared. I have to do the same thing to the top. I cannot just decide to multiply the bottom by y squared without multiplying the top. Is that clear? Do we remember this? Right? Okay. So then the numerator becomes 16 plus y to the 4th minus 8y squared. When is a fraction 0? Or you say it's over 1 and you cross multiply. Or when is a fraction 0? And the answer is when or cross multiply. When what? Excellent, thank you very much. So y to the 4th minus 8y squared plus 16 equals 0. It has to be arranged in descending order. And now we have to dig deep again. What type of equation is this? It is quadratic in form. Very good. It's a polynomial. What is the degree? How many solutions we have to write? Right. We know that from polynomials. Good. So you either notice how to factor or use a substitution. This is not a substitution for systems. This is a substitution for solving a quadratic in form equation in which this could be denoted by t because that is for sure what? Excellent. Only because of that I can use this method of substitution, or because it's quadratic in form. That's why I can use this method. Okay, so then how do I factor this? Say it again.
8 and 2.
4 and 4 indeed. That's why I only wrote one product. So this is t minus 4, so t equals 4. But this really means that y squared equals 4. You can say, well, where are the other two coming from? Same thing. It's t equals 4 twice. So we will end up having 4 solutions. Some of them will be the same. So how do I solve this equation? Which method? Right. Yes. So y equals plus or minus 2 and y equals plus or minus 2. In other words, there are 2 of 2 and 2 of negative 2. That's all it means. So now what follows next? I have y, but I haven't finished, right? I have to go back to x equals 4 over y. So I have that y equals plus or minus 2 if you want twice, because we talked about 4 solutions. So each of them appears twice. But then I have to go back to x equals 4 divided by y. And from here I will get 2 different x values. What are they? So how much is x? Correct. Very good. Positive 2 and negative 2. But now we have to write 4 solutions. So when x is 2, y is 2. When x is negative 2, y is negative 2. And I will have to repeat. It doesn't mean that it has 4 solutions. It has 2 pairs of identical solutions. Any questions? Do we understand how to handle at least the substitution method? At least the substitution method, I'm not sure what is going on with my video. The substitution method for nonlinear systems. Should we look at elimination now? Okay, so let's take a look. Let's start with 20 on the same page, 587. And then we can look at word problems. 4x squared minus y squared equals 4, and 4x squared plus y squared equals 4. In this particular case, you can use substitution and elimination. You can solve, for example, for y squared from here, and then plug it in here. So it's very possible. However, there is no need. Look at how nice these two go away. With 8x squared equals 8, and therefore x squared equals equals 1. Perfect. Which means x equals plus or minus 1. Good. No, good, but not good enough. We have to go back and find y. So with x squared, we go back to the first equation. So 4 minus y squared equals 4. Negative y squared equals 0, or y squared equals 0. And we expect 2 solutions. However, they are both the same. Would you agree? What is the solution for y? Perfect. So there are 2 options. 0 in both cases for y, 1 or negative 1. And yes, we can go back and check, and both will work. Let me know if you'd like to work on another problem with elimination of nonlinear systems. And we'll find another. Yes? Perfect. Well done. So let's look at 38. And this one is on page 589. And we have x squared minus y squared minus 4x plus 6y minus 4 equals 0. And x squared plus y squared minus 4x minus 6y, plus 12 equals 0. I have to check one more time. X squared minus y squared minus 4x plus 6y minus 4, that's correct. X squared plus y squared minus 4x minus 6y plus 12 equals 0. Very good. There is no way we can use substitution on this system. How come? It's because, first of all, if I solve this equation for x or y, I really can't because of x squared and y squared respectively. So I can't really use substitution here. So I'm really hoping that elimination works. And I see something interesting, that if I add these two equations, these two terms go away and these two terms go away, and the resulting equation is an equation in x, which means 2x squared minus 8x and plus 8 equals 0. I will simplify by 2, always recommended, and then I get x squared minus 4x plus 4 equals 0, which is a very easy situation to handle. I only have to remember how to factor this. And once I have, or if I don't remember how to factor, you can use the quadratic formula. But it's quite easy to factor. Can anyone give us the factored form of this trinomial?
-2.
Yes, perfect. X minus 2 squared equals 0. Two solutions, however, twice the same thing. Now, with x equals 2, I go anywhere. It doesn't matter, the first equation or the second equation. I replace x everywhere with 2, and I solve for what? Excellent. Which equation would you like to go back to? It doesn't matter. Top or second one? Okay, I'll go back to the second one. So I have 4 plus y squared minus 8 minus 6y plus 12 equals 0. I combine like terms, arrange it in descending order, and then get y. So I have y squared minus 6y. This 16 minus 8 is 8 equals 0. Again, I'm hoping that this is easy to factor. If not, I will use the quadratic formula. No problem there. What do I get? Yes, y equals and y equals. So it's y minus 2 and y minus 4, so 2 and 4. I have to present the solutions. In this case, 2 solutions. And what do I get? The solutions are?
2, 4.
Very good. 2, 4 and
2,
2, 2. Yes, we should always go back and check and make sure, especially on a test situation, make sure that they work. Okay, so let's look at a word problem this time. Okay, let's look at problem 60. You may encounter something like this. Maybe you already bought your first home, so you may be interested in replacing the carpet on your own. Who knows? The area of a rug, or putting a rug somewhere, the area of a rug is 108 square feet. And the length of its diagonal is 15 feet. Find the length and the width of the rug. They're not telling us, but we assume that it's a rectangular type of rug. Okay, so the area is 108 square feet and the length of the diagonal is 15. Find the length and the width of the rug. First of all, how many variables we have in this problem, because we need to give them a name or a letter representing them. What do you think? Okay, let's read the problem one more time. The area is 108 square feet. The length of the diagonal is 15. Find the length and the width of the rug. So how many variables we are looking at? 2. So x, length and width. How many equations we need to create? 2 equations, because we have 2 variables. Very good. Can anyone give us any of those? Give it a shot. It's okay. We all make mistakes. It's fine. I just want to see what you're thinking about.
Do x squared plus y squared equals 15.
Exactly. X squared plus y squared equals 15 squared. The sum of the two legs squared equals the hypotenuse squared because this is a rectangle and we are talking about a right triangle. Excellent. That is one of the equations. That's why this system is not linear because x squared plus y squared equals 25. It's not equals 225 is not a linear equation. Perfect. But we need one more. What do you think? Say it again.
X times y.
Very good. The area x times y equals 108. This is indeed a system. As you see, none of the equations is a linear equation. So the first one, quadratic. The second one, it's basically not even quadratic. It's a rational equation. Y equals 108 over x. Good. The variables are not the same. So obviously we are not going to be able to use substitution, elimination here. The only chance we have is substitution. So we solve the second equation either for x or for y. You choose. It doesn't matter. Good. Okay. So this is 108 over x. So then I have to plug in y in the first equation. So this will be x squared plus 108 over x everything squared equals 225. So then x squared plus, so how much did you get, Heather?
225.
No, in 108 squared.
Oh, I don't know. I didn't do that part.
Oh, I thought you already did.
No. A lot. 11,664.
Like this?
Yep.
Perfect. Okay, again, like the previous situation, when we looked at that equation, nonlinear, the same thing. I have to move to a 25 if you use this method. You don't have to. I recommend this method because I think it's well structured and I think you can follow through and understand it. But if you have a shortcut, I'm fine. So we have x squared plus 11664 divided by x squared minus 225 equals 0. Like before, we have to find the LCD, and we have to find adjustments. We cannot just simply add or subtract. We have to look at the necessary situation here. So then what do we have? So this one needs an x squared. This one needs nothing or 1. And this one needs also an x squared. So we have x to the fourth. I'm going to write this next. Negative 225 x squared and plus 11,664. So again, we have two options. You either cross multiply, considering a proportion, or you say, oh, when is a fraction 0? Only when the top is 0. And you just go ahead and write x to the fourth minus 225x squared plus 11,664 equals 0. Again, you either notice that this is quadratic in form when you use substitution, or you try to factor. But I notice that this is t, and then this is t squared, so then the equation is t squared minus 225t plus 11,664 equals 0. I'm not going to worry about this, obviously. Negative b plus or minus b squared minus 4ac over 2a. This is what I'm going to use. So I will put in the calculator. Okay. I didn't get the chance to read my. This computer has what it's called a deep freeze. Once you log out, everything gets deleted. Why? I have no idea. Okay. So I have in parentheses 225 plus the square root in parentheses 225 squared and minus 4 times 11664. 11664. Close the parenthesis, go outside, close the parenthesis and divide by 2. And of course, I need to determine the other one with a minus. And I get 81. So there are two options for t. T is 144, and the other t is 81. But who cares about t? We're not interested in t. We're solving for x. Can anyone create a new equation that we need to solve for this, and a new equation that we need to solve for that? What do you think? We denoted by t, x squared was denoted by t. So we have x squared equals 144. And then x squared equals 81. Then we take the square root on both cases. So then we get x equals plus or minus 12, or x equals plus or minus 9. But you have to say, wait a minute. We're talking about x and y positive. There are distances, length, and width. So they can be negative. So then the option is for x, not these. You don't have to cross it out. You just have to say x equals 12 or x equals 9. Now I have to go back to y. Y was 108 over x. So therefore, y equals 108 divided by x. So therefore, there are two different x values. And so therefore, we're going to get two different y values. So when x equals 12, y equals. And when x equals 9, y equals. So it's 12 and 9. I'm sorry, the other way around. 9 and 12. So it doesn't really matter how you present the answer. Because we do have two options. 12, 9 and 9, 12. But it's basically the same thing. Any questions? Any questions for me? Doesn't this at least seem to be easier than log equations and exponential equations and right? No? No?
That's right.
Okay. So you like the exponential ones better? Good. Okay. There is a little bit more work, but okay. Last section of chapter 5. So 5.5. This is something that you also, I'm sure you remember from your past experience with math, systems of inequalities. They can be linear or nonlinear. Okay? They can be linear or nonlinear. So let's take a look. Of course, in this case, we will not be able to present the solution as an ordered pair. We have to graph. So when we are asked to solve a system of linear or nonlinear inequalities, we have to present a shaded area on the coordinate system. We're not going to be able to say 2, 3 and 5, 9 or negative 3, 2. That's not going to happen. So this is a much complicated situation. So let's start with simple linear inequalities, systems of linear inequalities. Let's start with 30 on page 600. And where we have 2x minus y is less than or equal to 4, and 3x plus 2y is greater than negative 6. There are several steps that we need to follow here. What type of system is it? I will say it's a system of two linear inequalities in two variables. What do I have to do first? Number one, I will start with the first inequality. It doesn't matter. The order is not important. And I will write, I'm not changing the inequality into an equation. I need to graph the equation. That's why I write the equation first. But I am still solving the inequality. So I write the equation because I need, in the first step, to graph it. So first, I write the equation. In step 2, I graph 2x minus y equals 4. And we know how to graph this because it's a linear function, right? We need to find the x and y intercepts. So when x is 0, how much is y?
-4.
Excellent. So 0, -4 is our first order pair. When y is 0, how much is x? 2. So then 2, 0. So let's go back. We didn't finish. We're not yet there, but let me just refresh your memory or summarize the information the steps we performed already. Number 1, I identify this as being a system that is a system of inequalities, linear inequalities in 2 variables, 2 equations, 2 variables. Number 2, I rewrote the first, or I created the corresponding equation to the inequality. I'm not changing the inequality into anything else, into an equation, but I'm just writing the equation because I need to graph it. In step 2, I found the x and y intercepts. In step 3, I will graph, or that's part of step 2. In step 3, I will graph the inequality, but not yet. So let's put in 0, -4, and 2, 0. I want to graph this equation, but I have to make sure that this, or just look and see whether the inequality symbol has the equal symbol or not. If the inequality symbol has the equal symbol, I will graph the line as a solid line. And that's exactly what I'm doing. The inequality has the equal symbol, so I'm graphing as a solid line. And this is 2x minus y equals 4. So that was still step 2. You know, to graph, I found the x and y intercepts, and I graphed the equation. I write somewhere close to the line, below, above the line, left, right, it doesn't matter. Somewhere I wrote the equation. At this point, I reached step 3. In step 3, I check with a point. I will always use the origin, use 0, 0 if the line does not pass through this point, through 0, 0. If it does pass through 0, 0, choose another point. Okay, so I check with a point. I see that the line, this line, divides the entire area into 2, or region, into 2 pieces, this piece and this piece. I also know that the origin is right here, in the upper piece, in the upper region. So I will plug in 0, 0 in the original inequality, 0, 0. And I get, when I check the inequality, I get 0 less than or equal to 4. If you say that this is a true statement, then I go back to the inequality and I will shade in the region that contained 0, 0 because it created a true statement. What if this you say, no, 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 it's not true, it's false? Then I will have to select the opposite territory. So question is 0 less than or equal to 4? Yes, of course, 0 is less than or equal to 4. Therefore, we will shade in all the area above the line, and somewhere in that region, we will write 2x minus y less than or equal to 4. Let's stop for a moment before we continue. What does this mean? It means that if you ask me to solve the inequality 2x minus y less than or equal to 4, I have no way of presenting the solution except to show you this graph. The shaded green area. I don't have any other way. However, we are only halfway through. Why? Because we only solved the first inequality. We did not get the chance to solve the second inequality. So we perform the exact same 3 steps using 3x plus 2y equals negative 6. So 3x plus 2y equals negative 6. I wrote the equation because I have to graph it. I will find what happens when x is 0. How much is y? Very good. Y is 3. So we have the first ordered pair 0, 3. And now when y is 0, so sorry here, negative 2, sorry. I just realized that. Very good. So when y is 0, x is?
No, negative 3.
So that was, so negative 3, yes. Sorry. Pay attention. I'm talking to myself. So that was when x was 0, y is negative 3. Sorry about that. So 0, negative 3. And now when y is 0, x is indeed negative 2. And negative 2, 0 is perfect. We go back to the same coordinate system. We graph both on the same coordinate system. So you said 0, negative 3. Okay, 0, negative 3 is here. Then you said negative 2, 0. Okay, fine. Here it is. But now, before I graph, I have to look at the inequality symbol. Does it have the equal symbol? No. Since it does not, I can no longer graph, or I'm not allowed to graph it as a solid line. Somewhere on the line, I will write that this represents 3x plus 2y equals negative 6. The next step is I have to solve the inequality. I see now that this line divides the plane into 2 regions. The region above that has the origin and the region below that does not. I'm going to use the origin again, but this time for the second inequality. And I have 0 greater than negative 6. If you say that this is a true statement, I will shade in the region that has the point that I used to check. If you say this is false, then I will shade in the opposite. Is 0 greater than negative 6? Yes. So therefore, all this region that is purple represents 3x minus 2y greater than negative 6. All the ordered pairs that verify this inequality are found in the purple region. But this is a system. I want both inequalities to exist at the same time or have a solution at the same time, so the system has solutions. What will I have to do finally?
Find where they're both shaded.
It's like the common domain. Similar. I have to intersect the green region with the purple region. And where they overlap, I will find the solution to the system. So all points on this line, not points on that line, but very, very close to it, but not points on that line, and everything in between. So what is this? Both at the same time. If I want to pick an ordered pair that verifies both inequalities at the same time, I have to pick in the orange region. That's where the green and the purple meet. And that's what I need in order for the system to have solutions. Any questions? Any questions? Do you remember this?
No.
That's okay. That's okay. It's okay. Okay, let's look at another example then. Do we understand the steps? So we write the equation, we graph the equation, we graph the inequality, we shade in, right, for graphing the inequality. then we repeat the same steps for the second inequality, or the third, or the fourth, it could be. And then at every step of the way, we intersect with the previous region. Any questions? Okay, let's see another example. Let's this time look at the nonlinear system. Let's look at 54. And that is still on page 600. X squared plus y squared less than 4. And y minus x squared, and I say it's greater than or equal to 0. Okay, so the first step is still the same. I have x squared plus y squared equals 4. And now I have to remember what this is. So what is it? Anyone remembers from chapter 2? Yes. What is it? What is this?
It's a circle.
It's a circle. It is a circle. What is its center? And what is its radius? 0 and 0. It's centered at the origin, and the radius is? Very good. So let's graph it. Well done. Please remember, that's why we need to review for the final exam. That's why I'm trying to get there. Finish this review for test 3, take test 3, and then for the rest of the couple of weeks, just review, because we need this. Okay, 2, 2, 2, 2, 2, 2, 2, 2. But the question is, do I graph it as a solid curve or not? Not. Very good. So this circle has the equation x squared plus y squared equals 4. I want to point out something very important. On the line, you write the equation. When you solve the system or the inequality, you write the inequality. So please do not write this on the line. That's not the case. Okay, please pay attention to that. Good. Now I see that the circle divides the entire plane into 2 regions, the inside one and the outside. So this region inside the circle and this region outside the circle. But the idea is the same. I'm going to check the inside of the circle with the origin, because that's the easiest thing to do. Can you use this point 10, 10? Yes, but why would you? There's no point in multiplying. 0, 0 is the best. 0, 0. Is 0 less than 4? If you say yes, I will shade in the area inside the circle. If you say no, I will shade in the outer part of the circle, the area around the circle. Would you say that this is true? Yes. So then we will shade in everything inside. And the inside, not the circle, but the inside is x squared plus y squared less than 4. I continue with the second one, which is y equals x squared. Let me write it as y minus x squared equals 0 first, and that changes into, we've seen this like we're completely fed up with it. What is the graph of this? We graphed it like at least 15 times. What is it? What is it? What is it? Say it again. Of course, it's a parabola with a vertex at the origin. We graphed this many times. Okay, so I know how to graph it. It goes through 1, 1, 1, 1, and 0, 0. But the question is, do I graph it as a solid curve? Yes, indeed. Solid curve. This is just the equation. This is y equals x squared or y minus x squared equals 0. Since this curve passes through the origin, I cannot use the origin to check. I have to determine another point. That's not a big deal at all. I'm going to use this point, 0, 5. Anything that has 0 in it, because it's so much easier. So x equals 0, y equals 5. 0, 5. Is 25 less than 4? If you say yes, I will shade in the inside. If you say no, I can shade in the inside. Is 25 less than 4? No. So then I have to shade in the outside. So all the orange region represents y minus x squared greater than or equal to 0. So now we have to intersect because we are solving the system, not each individual inequality. We have to intersect the orange with the green. Do they overlap? If they don't overlap, then we'll say immediately, sorry, no solutions, done. But if the orange territory and the green territory overlap, then we have solutions. The system has solutions. Do they overlap? Yes. Points on this curve, all points on this curve. Not points on this curve, but very, very close to it. Extremely close to it, as close as possible. And of course, everything in between. So this is both. If you don't want to write both, just write system. So now, if we pick solutions or order pairs here, only the second inequality is fulfilled. If we pick in here, only, or here, here none. Here, only the first one. But if we pick here, the system has solutions. That's where the solutions of the system are. I would not be able to show in any other way but graphic, in a graphing matter, by graphing the inequalities. That's the only way. So I never said that before, but I'll say it now. We know that solving and graphing is not the same thing. Most of the time it's not, but in this case it is. So when we're asked to solve a system of nonlinear inequalities or linear inequalities, we're actually asked to graph. When we're asked to graph, we're actually asked to solve. Okay, we have time for another. Would you prefer linear or nonlinear? Nonlinear? Yes? Very good. I completely agree. I would have suggested that. 56. Same page, 600. X squared plus y squared less than or equal to 16, and y less than 2 to the x. Very good. So the first one has no difficulties, right? Is x squared plus y squared equals 16, and we know what this means. What does it represent? A circle, and the center is, and the radius is. Right, indeed. We don't subtract anything from x and y, and we don't add. So, and the radius is 4, indeed. We have no other options but graph. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. I stop and I think and I look. Do I graph it as a solid circle? Yes? Very good. It is yes. It has the equal symbol, so it has to be a solid circle. My circle is anything but a circle, but please say, imagine that it is. My apologies. It's not perfect. So this is x squared plus y squared equals 16. And I promise I will not look at your graphs with the magnifying glass. So this is good. Now I have to solve the inequality. Yes. Any questions? Ladies, Any questions? Michaela? Any questions? I see cell phones, so I don't know why. It breaks my heart, but so then I check with 0, 0. The graph does not pass through the origin. So when I check with 0, 0, I get that 0 is less than or equal to 16, so I will shade in the inside. The inside is the inequality. So please do not write the inside as the equation or vice versa. Okay, the next step is I have to graph y equals 2 to the x. And now I have to dig deep. This is the chapter that we just finished. And what is it? And how do we graph it? How do we graph this? What type of function is it? Say it again. Very good. Exponential. Great job. Increasing on all its domain or decreasing on all its domain? Increasing. Solid curve or not? Not. Very good. Awesome. So it has to cross, if you remember, at 0, 1. It has a horizontal asymptote y equals 0. So this is 2 to the x. It divides the entire plane into 2 regions, the one inside and the one outside. I'm happy. It does not pass through the origin, so I will use the origin. So the left-hand side is 0. The right-hand side is 2 to 0. How much is 2 to 0? 1. If you say that this is a true statement, I will shade the region where the point I used is coming from. If you say this is false, then I will have to shade in the opposite. Is 0 less than 1?
Zero less than 1.
So then all this purple, whatever color this is y less than 2 to the x. Now do these 2 regions overlap? If they overlap, the system has a solution or solutions. If they don't overlap, we'll say no solutions. Do they overlap? Yes? Very good. All points on the curve, that is the graph of the circle. And very, very close to this, but not points on 2 to the x. So this is both. Or where you see orange, the orange area is